Does increasing the percentage of infill always increase the impact strength of a 3D printed part, or does the impact strength increase become negligible after the infill percentage exceeds a specific threshold? With this study, we wanted to find out. Why do we care? 3D printing has become very common, and it's useful in a wide variety of fields.
The problem with optimizing the strength of 3D printed parts, however, is that there are many different factors in play. For this study, we investigated the infill density.
And finally, why impact strength instead of something static like ultimate strength? For many robotics applications, impact strength is the limiting factor for parts, not static strength, so that's what we're testing.
We used a DIY IZOD impact test with samples printed on an FDM 3D printer, the Elegoo Centauri Carbon, with Elegoo PLA Plus filament. The samples were in groups of different infill densities, and all other settings were kept the same as shown on the right. After all the samples were printed, we destroyed them for statistics.
The initial height of the pendulum was known, and the final height of the pendulum was measured. So by using the mass of the pendulum, we could calculate the energy required to break the samples, and thus the impact strength of the samples.
Before we get to the results, there are some serious limitations to the study. All samples were printed on a single printer with a single roll of filament at an unknown uncontrolled temperature, and no variation in print settings. So statistically speaking, the results of the study only apply to a minuscule set of all 3D printed parts.
However, if we ignore the need to be correct, and assume that all 3D prints are similar enough in those respects, then we find that there are potentially some important implications of the data. Between 10 and 20% infill, there is no change in impact strength, while between 20, 40, and 60%, there are significant changes, with the impact strength increasing by around 60% between 20% and 60% infill. Finally, between 60% and 80% infill, there is no significant change in impact strength. This means that if anyone is trying to print a part and minimize filament usage, there is no point going over 10%. And if someone is trying to maximize strength, there is no significant benefit in exceeding 60% infill.
This is all assuming that the user only cares about impact strength as a property of their part, and that the research can actually be generalized to all varieties of FDM 3D printers and all variations of print settings, which it can't. So take everything with a grain of salt.